So earlier we talked about this table and I told you that the size of these data types is dependent on the system. But on most systems, it's fair to assume that a short is 2 bytes and an int is 4 bytes. But now let's do something fun. Let's investigate the size of each of these data types on our machine. I'm going to show you one of them as an example, and I want you to do the rest on your own. So back to our code. Here we have a function called sizeOf. We can call this function and give it a data type like int, and this will return the number of bytes required to store an integer on this machine. So let's print it on the console and see what we get. All right, on this machine, an integer is 4 bytes. Now, I told you that in 4 bytes of memory, we can store the numbers from -2 billion to +2 billion. Let's investigate that too. So here we're going to use a class called numeric limits. We'll talk about classes later in the course. For now, think of classes as building blocks of our programs. So we have a class called numeric limits. Now, this is what we call a generic class. So after it, we have to type angle brackets, and in between the brackets, we specify a type, in this case, int. Then we type double colons to access the members of this class. Again, we'll talk about this concept in the future. Now here we have two functions. One of them is min, the other is max. So we call this function that belongs to this class or this block. Then we add a new line, and on the next line, one more time, let's use numeric limit of int and call the max function to see what is the maximum value we can store in an integer. Now, let's run our program. So as we can see, we can store numbers from -2 billion to +2 billion. Now, what do you think will happen if we store a number outside of this range in an integer? Let's find out. So let's declare an integer called number and set it to the maximum value we can store in an integer. So I'm going to grab this piece of code, cut it, and move it here. So this is the largest integer we can store in this variable. Now, let's increment this by 1 and then print it on the terminal. What do you think we're going to get? We get -2 billion. So if the value we want to store in a type is too large for that type, it will wrap around to the type's minimum. This is called overflowing. Just like we have a bucket that is filled with water, if you put too much water in this bucket, it will overflow, right? We have the same concept in programming. So here our integer variable number has overflowed. We stored a number that was too big for it. And that's why that number is wrapped around to the type's minimum. Now, in contrast to overflowing, we have underflowing. So if we set the number to the smallest value we can store in an integer and then decrement it by 1, this number variable will underflow and it will wrap around to the largest value we can store in an integer. Take a look. So run. There you go. The largest value we can store in an integer. Now, as an exercise, I want you to use what you learned in this lesson and find the size and limits of a couple more data types on your machine.